Today's lesson is on box and whisker plot. This is something that used to be taught in the higher level grades, but now it's taught in 7th grade, so it's a new topic to 7th grade this year. A box and whisker plot, and I'll tell you why that's called that in a little while. But the definition is it's a numerical way of characterizing a set of data. And all you're using is median for this kind of graph. What it does is it breaks the data into quartiles. A quarter is like 1/4 of a dollar. When you're done breaking the data into quartiles, it's a set of quantitative data that can be divided into 4 equal parts. So all it does is it breaks the data into 4 equal parts. The 2 parts, or the 4 parts I should say, of a box and whisker plot, there's the upper quartile, which is median of the data values that are greater than the median. So this is like the middle of the upper half. The lower quartile is the median of the data values that are less than the median. So again, this is like the middle of the bottom half. So we have the upper quartile, lower quartile. The interquartile range is the difference between the upper and lower quartile values. So I'll show you in a little while though, these are very closely related because they become the box of the plot. The maximum value is the largest one. The minimum is the smallest one. Sometimes you'll see a number that doesn't really belong with the rest of the data. That's called an outlier, sorry. An outlier is a data point that is numerically distant from the rest of the data. So if I have a bunch of numbers that are all single digits, and then I have like 40, that would be called an outlier because it doesn't really go with the rest of the data. So our example here, the owner of a restaurant wants to find out more about where his patrons are coming from. He gathers data about the distance in miles they travel to eat at his restaurant. The information below represents how far each patron traveled. So these are all distances people travel to come to his restaurant to eat. So he wants to create a graph that helps him understand the spread of distances and the median that people travel. So step number 1, we order the numbers from least to greatest. So here's our order. Oh boy, hold on. Sorry. Here's the order from least to greatest. We determine the median number of the data. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 14, 15, 16, 17. So remember from yesterday, we add 1 to that. That's 18. Divide that by 2. The 9th number is the median. 1, 2, 3, 4, 5, 6, 7, 8, 9. That number right there is the median of the data. Now what we do is we've grouped this now into the upper half and the lower half. 6 is the median. It's dead center in the middle. We then find the median, or the middle of the bottom half, this half right here. So when we do that, we find out it's 2.5, right in the middle of 2 and 3. Then we find the middle of the upper half. Here's my upper half of numbers. I don't use 6 again, 6 is the middle. And we find out it's 12.5, right in the middle of 11 and 14. So I have now 5 values. I have my minimum value right here. I got my median, or my lower quartile, 2.5. I have my median, my upper quartile, 12.5, and 30, which is my maximum number. Those 5 numbers become my box and whisker plot. So we're going to continue to the next page. These reference points divide the data into 4 equal parts. These are called quartiles. So 1/4 of my data is the same as 25%. So each section of the data represents 25%. So what I do next is I make a number line that contains all my data points, including the minimum to the maximum. And I use a scale that's consistent. So I went from 0 to 10 to 20 to 30 to 40. So what I did next is I plotted those 5 points. So I have 1, which is my maximum right here. Then I have my lower quartile. Then I have my median, upper quartile, maximum. The box right here, this box, see this box right here? That box is made by connecting the upper quartile to the median to the lower quartile. This right here, this area, is the interquartile range, this box. The whiskers become the box connected to my maximum value and my minimum value. So to recreate a box and whisker plot of the following set of data that represents Northeast states and their population in millions. I put these numbers here, all these numbers in order from least to greatest. I find the median, and in this case the median is right in between these two numbers. So I find that middle number in between those, add them together, divide by 2. Then I take this group of numbers. Now in this case I'm going to include 1.3 in the lower half because my median wasn't one of the numbers. I find my lower quartile, which is 1 right here. This is my minimum, 0.6, smallest one. My upper quartile, 8.8. And my maximum number. So I have 5 data points. Minimum, first quartile, median, upper quartile, maximum. 5 numbers you need to make this plot. Again, my inner quartile right here is made from my lower quartile, median, upper quartile. The whiskers become the minimum and maximum value. Now if you notice, see how long this whisker is over here? This is not really like the rest of the data. That can be called an outlier. So you have one small whisker here and one large one over here. This is an outlier. It makes a large whisker. So we can use box and whisker plots to answer questions. The box and whisker plot shows the profits of a software company in the last 10 years. Find the median. The median is dead smack right here in the middle. So we use the chart above, 15. And you notice it says it's in $1 million up here in the question. So the answer would be $15 million. On to question 4. The box and whisker plot below shows the earnings in dollars of a daily wage earner. Find the range of his earnings. To find the range, we take the biggest number, which is right here, the maximum value, 200, and subtract the minimum value right here, which is 75, which gives us $125. Question 5. The box and whisker plot of girls and boys. Which of the following is true? Choice A, the minimum height of the boys, right here, is equal to the minimum height of the girls. Here's the girls, here's the boys. Not close. Minimum height of the girls, which is here, is fairly close to the maximum height of the boys. That's down here, that's not even close. C, the maximum height of the girls, which is right here, is fairly close to the maximum height of the boys, right here, which is true, they're very close. So it's choice C. Number 6. Find the interquartile range. This is the interquartile range from here to here, where the box is. Now there's no median here, so no big deal. But we have 37.5, the big number, minus 12.5. And if you notice over here, I have the wrong answer. Bad, Mr. Bush. So when I do that, I get 25 for my answer. That's the correct answer. Example 7. Box and whisker plot represents the ages of 12 people. What percent of these people are age 15 or older? Here's age 15. This section right here is 25%. This section right here, 25%. This right here, 25%. So I have 3 groups of 25%, which gives me 75%.